Hello all, let's start section 3.7. Section 3.7, we are discussing modeling using variation. The first topic that I want to discuss here is modeling problems using direct variation. Let's first learn what is direct variation, correct? Or which kind of variation. We call it a direct variation. When you have two quantities that they are depending on each other, correct? When I have two quantities, for example, hours of work and salary. Hours of work is a quantity, right? Because in general you can call it time. Salary is another quantity. These two quantities has a relation, and we call this relation a direct relation. Why? If you work more, you get more money. Your salary goes higher. If you work less, your salary goes at the same time down, becomes less. Or in general, when one quantity is increasing, at the same time the other quantity is also increasing, or if one quantity is decreasing and the other one is also decreasing, we call the relation between these two quantities a direct variation. In general, if I name, for example, the number of hours or time y and my salary x, the relation between these two quantities is direct. Then I can write y equal x. The only thing that I want to add in this equation is a number k, which my equation will be y equal kx. K is a number, it's a constant, correct? K is a number, it's a constant, and we call it the constant of variation. X and y are your quantities, correct? Then the formula for a direct variation is y equal kx. We use this formula in our daily life a lot, even without knowing that we are using a direct variation. Maybe in the past in school, your teachers taught you this subject as a proportional, correct? One quantity is directly proportional to the another quantity. Here in this book, we are using the word variation. Proportional or variation, they're kind of same, right? Now, my general formula for a problem for the direct variation is y equal what? Kx. K is the constant of variation, y and x is your values or quantities. Now, in this section, we are dealing with the word problems, but believe me, the easiest word problems that you ever seen. We call it variation problems, and we solve it in this section. I'll do first one example. I'll just make one example here for you. Then I'll copy another example from your book and I will discuss. For example, you are traveling from a point A to point B, from one city to another city. If your car can go 20 miles and using 1 gallon of gas, correct? They're asking you, if you use 5 gallons of gas, how many miles you can travel, correct? If with 1 gallon gas you can travel 20 miles, with 5 gallon gas, how many miles you can travel? Of course, this is very simple. I use simple numbers, but they can use even decimal numbers or different numbers, correct? How to deal with these problems? First, when you are dealing with the direct variation problems, please follow these steps. Step number 1. Write an equation. Write an equation that models the given English statement. That models the given English statement or word or sentence, correct? Look, 20 miles, 1 gallon, you can travel 20 miles. What I do, I use G for gallon of gas and I use M for the mileage. If with 1 gallon I can travel 20 miles, with 5 gallon, of course I can travel more mileage. And I easily understand from this statement that I'm dealing with a direct variation. Then my first, I will write G equal Km. Correct? That will be my first equation that I make in step 1. Step 2. Substitute the given pair of values. Substitute the given pair of values. Pair of values into the equation. Which pair of values? Whatever in the statement is given. 1 gallon, with 1 gallon you can travel 20 miles. Then you can write 1 equals K times 20. That's your step 2. Solve it. Find the value of K, which is the constant of variation. To solve this equation for K, you have to divide both sides of your equation by what? By 20. Then you can write K equals 1 over 20. That is the constant of variation. It means in step 2, always with the variation problems, you have to find the value of the constant of variation. Step 3. In step 3, replace K in the first equation that you actually found, right? Your first equation was G equal K times M. Replace the value of K in this equation. Then you can write G equals 1 over 20 times m. That's your step 3. Step 4, read the last part of the problem and see what they are asking you. They are asking you in the last part of the problem, find 5 gallon, how many miles? If you use 5 gallon, it means you know how much is your G. Your G is 5. 5 equals 1 over 20 times m. Now solve this equation for m. You have to multiply both sides by what? By 20. 5 times 20 gives you 100. Here 20 cancels out with 20. 100 equals m. Here you go. It means if with 1 gallon gas you can travel 20 miles, with 5 gallon of gas definitely you can travel 100 miles. Correct? This example was really easy that I used for you to just explain. Now I'll copy an example from your book and we will solve that example together. Correct? Example number 1 of your book. Let me read it from your book. The volume of a blood B in a person's body varies directly as a body weight W. Correct? The volume of the blood. The volume of the blood, correct? The volume of the blood, we use letter B for the volume of the blood. And a person's body varies directly to the weight. If I use W for the weight of the person, correct? The volume of the blood varies directly to the weight of the person. It means I can write B equals K times W. Now I'm reading the second part of the problem. A person whose weight is 100 pounds or 160 pounds has approximately 5/4 of blood. Estimate the number of quarters of blood in a person whose weight is 200. Okay, now a person that weighs 160 pounds has 5/4 of blood. They are asking you if a person now weighs 200 pounds, how much will be the volume of the blood? My step 1 is to find K. What I do, I'll use W and I'll use B, replace it in my equation, and I'll calculate how much is K. Correct? Then I can write 5 equals K times W, which is 160. If I solve this equation for K, I have to divide both sides by 160, correct? Then I can say K equals, how many times? 1 over 32, correct? That will be the value of what? The constant of variation. Now I'll rewrite my equation. I will write B equals 1 over 32 times what? W. Now I'll focus on the last part of the problem. W is given. I have to find B. I'll replace the value of W in this equation. Then I can write B equals 1 over 32 times 200. It means B equals, if you calculate this, it gives you, let me calculate this one for you. 6.25. 6.25 quarts. You see, when you had 160, when a person had 160 pounds weight, he had 5 quarts of blood. When it's 200 pounds, it goes a little bit higher, 6.25. Now, if they ask you, what if a person has, let's say, 100 pound weight, immediately in your second formula, you can calculate how much will be the volume of the blood in that person, correct? The most important part of this problem is how to create your equation, correct? That's the important part of the variation problems. The next part of this section is inverse variation, correct? Inverse variation. Now, what is inverse variation? Again, if you have two quantity, when one of them is increasing, the other one is decreasing, or when one of them is decreasing, the other one is increasing, we call the relation between these two quantities inverse variation. For example, number of hours and work. One person, for example, can paint a room maybe in 5 hours. Two person can paint the same room maybe in 2 hours. You see, when one quantity is increasing, the other one is decreasing. This example will be a good example to explain the inverse variation. Then, if I name one of my quantities again y, the other one x, then y equal k over x will be the formula for the inverse variation. Again, k here is the constant of variation, y and x are your quantities. Correct? Let me do an example for you. Example number 1. Which kind of example, let's say? Let's use that example. One person can do a job in 5 hours. Find that 4 person can do the same job in how many hours, correct? Here I'm talking about the job and time, or in general, instead of job, you can say 1 hour can finish a work in 5 hours. 4-person, how long it will take for 4-person to do the same job or the same work, correct? I'm talking about time and work, correct? Then the relation here will be T equals K over W. My first step, like direct variation, I have to replace the value of T and W in this equation, correct? T was 5 hours. 5 equals K over W, which is 1. It means here K equal what? 5. Now I'll rewrite the first equation and replace the value of K. T equals 5 over W. Now, second part of the problem, how many people or person can finish the same job? Replace W with 4, then T equals 5 over 4 hours. That you can easily use your calculator, and it gives you few minutes. 5 over 4, right? That means 1 hour and how many minutes? 1 hour and 20 minutes, something like this. They can finish the job, correct? Variation problems, I just do a short lecture for you. And your test too, these problems will not be involved in the test. That's why I just did 2 examples. Practice with your homework. There is nothing much in this that I should explain to you. I only explained to you the direct and inverse variation. There are other 2 types of variation, which is combined variation and the other one, which is joint variation. Maybe we will discuss in future, but not now, correct? I'll stop the lecture here and see you all in chapter 4.